Okay. So please, Inari.
Yeah, thanks. Right. So I'm presenting Grammatical Framework and then a bit of subtyping afterwards. So okay, so so GF is a programming language for multilingual grammar applications, and so let's start. What is a multilingual grammar application? So say, oh, where's my? Right. So say that you have some like very formulaic text, like you have some database with some structured data and you want to generate a bunch of text that is always the same. Like it could be weather reports, it could be museum objects, like, you know, it's just different paintings, but you say the same things. So instead of writing that text in some language and then employing translators, you can write a grammar that does this. So why is it a grammar and not just a like string replacement? Is because maybe sometimes like you have different agreement, or like maybe this painting is a man and it has some wording of text differently if this painting is a woman or anything. Maybe for this might be so it doesn't have to be just like data. It can be even something very, like it can be a formal language and you can generate natural language out of it. I think maybe in 2 weeks you will see something that looks more like this. I'm going to stick to most natural language in this talk. But yeah, so we can also parse. So if we can parse natural language and we can generate natural language, then we can do machine translation. And just to get this out of the way, this is nothing to do with machine learning, like no neural nets, no sigmoid functions, whatever here. So we have this very good old interlingual way of doing things. So we would parse some Guten Tag into an abstract representation, and then we generate that into some other concrete language. So yeah. And then in the middle, this abstract representation is a grammar that could look like this. And then the concrete syntax could look, for instance, like this. Okay, so let's, I'm going to present an abstract syntax of a small example. So every programming language, you can do hello world. So that's suitable for GF as well. So we have categories, which are using the keyword cat. And here we have 2 categories, a greeting and a recipient. And then we have functions, as in funs. Like they can be single words, or they can take arguments and construct new phrases. And so here we have hello is a function that takes a recipient and greets that recipient. And world is an example of a recipient. So this is like very trivial grammar. This is the only tree we can construct, but it's a tree. Now, if we add a couple of more recipients, so we get a couple of more trees, but still very simple. Okay. So just, I want to, in case you get the idea that this is just for toy grammars, like this is an example of what I'm doing at my daily job. Like, but I thought I would spare you this kind of tree, and we're just doing hello world or something like that. Yeah. So right. So now I'm going to show concrete syntax. So for English, this is very simple. Like we can just, yeah. So we have in the abstract syntax, we had cats. So in concrete, we have link cats. And so in this case, we can just say that both are strings. And we had funs in the abstract syntax, and here we have lins. So these single words are just single strings, and the function that takes an argument just attaches another string in front of the argument. So this is very simple, and we get a parse tree now. So we can add a couple of more languages, and then we can do translation. Just like in that picture. Okay, so what other languages are there in the world? Like, I want to do Icelandic, so I'm going to consult internet how to say hello in Icelandic. And so I learned that, okay, so now you can't just say hello, you have to know who you are saying hello to. And apparently it's also different forms for plurals. And so now we need to use a couple of more language constructs in GF. So here we need to encode the recipient's number and gender. So we need parameters. So these are just like any algebraic data types in Haskell. Like you could do a product type if you wanted to, of those two. And then we have records, which, yeah, unlike Haskell, the names are not unique. So you can have, it's a convention that every record has or should have like a field called S that has a string or something. So now that we have the types, we can fill in some words. I got this from Wiktionary. I don't speak Icelandic, so if someone does and you notice mistakes, just let me know. And now here we have the logic of the greeting hello function. So it pattern matches the N and G, so the number and gender of its argument, and then it outputs one of these strings. If it's singular masculine, so it's cycle and whatever. Right, so now I just want to show you a couple of more GF language constructs first. So I'm going to rewrite this. So like this is actually already if I just put all these three pieces together, that would be already a valid concrete syntax for Icelandic, but I'm just going to try to get most out of this tiny example to present in GF. So now I'm going to let's put this in the table one. So first, so we have a new keyword, oper. Is like, these are helper functions for, like you can use them in the linearizations, but these are just like, these are only in concrete syntax. They will be compiled away in the grammar, but yeah, these are just like helper functions. And this is a table. So with this double arrow, that's a table, and single arrow is a function. And so this is a two-dimensional table from number to gender. So here you see it like it's singular branch. Then you check if it's masculine or feminine or neuter. And then like, so now this is an oper, so I could use it in the hello function. But so I'm just going to write it a little bit nicer. So I'm actually going to do this product type here. So my link of recipient is now, it's just two fields, S and A, but the A is just like all the combinations of number and gender, just like it was. And now I can write this table in one-dimensional form. Right, and then this is the exclamation mark is how you access the table. So this test evaluates to this string here, this style. Okay.
Can we ask questions, or should we wait until the end?
Oh, right. Yeah, sure. Yeah, yeah, you can ask anytime. So go ahead.
So simple, stupid question. What is the reason for having functions and tables? What is the difference really?
Yeah, that's a very good question. So the tables are, so the reason is that whatever you have to have on the left-hand side of the table, it has to be finite. So you can't have a table from string to string. Like you only can have a table from some parameter type to something else.
But couldn't you do a program analysis to recognize this and then spare the user from, making the decision? If it's a finite function, you could internally make it into a table or.
Yeah, I mean, I don't actually know if it's like, I don't know how it's implemented, but just like if you could, like it would be completely possible to just change this double arrow to a single arrow and like just write what like hello agr case agr off, and then like just the same code here.
I think it would be important for the user to know if it's a table or not, because only tables are invertible. So that might be a reason too.
Yeah,
Okay.
I don't know the implementation details, but like, yeah, it's like just conventions are that usually like inflection tables would be tables, and yeah, I guess sometime maybe you can, I mean, obviously you can write everything you can write as a table, you can also write as a function. And that is just, instead of like, if you wanted to get this string style out of this, so then you would just, instead of this exclamation mark, you could just put this thing in parentheses, this argument here. Any other questions? Okay, I'll continue. So, right, so while we were writing things to make them look nicer, let's also make like a nice looking constructor for this recipient. So now it takes as an argument a string, number, and gender, and then it puts it into this record so that we can write it like this. Like we don't actually have to write these braces and semicolons, so many on that line. It just looks nicer. Right. And now final thing, like we move all of these operators and parameters into a resource module like this. So this is like the kind of the low level stuff. And then we open the resource module in the actual concrete syntax. So a resource module can only have like parameters and operators, and the concrete files can have linkets and lins. So now this looks very much the same like the previous grammars that only had strings. Right, so now, yeah, now we have the complete grammar, and yes, we can parse and we can translate. So, right, that's the bit almost all the most important language constructs in GF that are. There are a couple of more things on the module structure, but I'm not going to talk about them now. So actually, right, I guess we had questions. Have you gotten any new questions, or shall I just go on?
Yeah, I think you can continue.
Yes, okay. So, right, so we have, so GF has, like the standard library of GF is called the resource grammar library, which is, so yeah, it covers the syntax and morphology for a whole bunch of languages. And like the point is that we implement all these low-level details in this library so that you never have to worry about, like when you write an application grammar, that you don't need to worry about you don't need to write anything about singular, plural, that kind of stuff. So I'm not going to go super into details, but just to show another application grammar in the legal domain, which is where I'm working at the moment. Yeah, I mean, this is completely out of context, so like don't try to, you don't need to know everything what's happening, but just like out of this code, like all these modules and types and operators these are all come from the resource grammar library. So we have some, for instance, this module is for irregular verbs, and that's where shall comes from. Passive VP comes from syntax. Yeah, like, yeah, so all these details that are like how do the words agree with each other? Like what's the word order? Where do you put the negation? Is there grammatical gender or not? Yeah, that's all in there. And like, so in this grammar, I've created one new linguistic distinction, which is whether objects are, do you break them or do you stab them? So, but like this is very specific, so you would not put this kind of thing in a Resource grammar library. So it's like my application grammar is a combination of like the semantics of what I want to express. Like I want to express that, okay, some things you stab and some things you just break. And then, but like whether you use a passive clause or something with those, that's like not my problem. Okay, any more questions?
Yes, so far this looked a bit like Haskell. So could you just do all this as a Haskell library, or I mean, is there any strong reason to have a specialized programming language like a grammatical framework, or is there?
I mean, the one big thing is that like when you write GF, you write a pretty printer and you get a parser for free. You can't do that in Haskell.
Right. Yeah.
So and like GF is not as expressive as Haskell. Like GF is not Turing complete. So that's like also one thing that like about these parameters and tables. Like basically, like you can't. Like all functions need to be invertible because like if you need to be able to linearize and parse. So if you, so that also creates all kinds of restrictions. Like if you have some function that takes like whatever, a noun and a verb, and then maybe you wanted to check that, oh, is that verb the copula? Like maybe it behaves differently if you say that I am I am a dog and I see a dog. Okay, and so like maybe in Haskell you could just pattern match the string that, okay, well, if the string is am, are, or is, then do this and then do that. But in GF, like all kinds of distinctions that you need to do, you have to have a parameter for it. And
right. So you could say I take some kind of discipline subset of Haskell, and then I can do the inversion in some kind of meta programming, maybe. Right. If I say, so not all functions are invertible, of course, but I could say if the function is invertible, then it's accepted. Otherwise, it's some kind of type error, which I do on top of Haskell. I think maybe traditionally this wasn't possible when GF was built, but it could be an alternative today if you would start from scratch to start with a general purpose language like Haskell, which has a lot of the structures you need, like records, data types, and alternatives, recursion, and all that stuff. And then you carve out some kind of benign subset, which you consider to be the GF, right?
Yeah, I think lots of people. I know, like Kuhn had his own GF Lite some years ago, and like I think like Andreas and Anka has also done something. Like I don't know, how far did you get, Anka?
Yeah. Okay, thanks.
Okay. But yeah, I mean, like I encourage I'm saying some things, but like I am by no means a Haskell expert. So like if I tell you something like, oh, this is not true in Haskell, maybe I'm wrong. So like if you see something that can be improved, so I believe you. Okay. So now so this was GF. So now I'm going to talk about subtyping.
Sorry, may I ask a question?
Yeah, sure. Wait. Just,
Hi.
right.
So I actually, if there's time, I wondered if you could, you mentioned things like local ambiguity, like in the case of predicate versus a noun phrase. I wondered if you might be able to quickly take us maybe through an example of how that sort of thing is resolved in parsing, how like that sort of ambiguity resolution is done.
Sorry, actually, I can you repeat just the beginning?
Right. I think so. You just mentioned the kind of ambiguity involving a noun phrase versus a predicate. I think you said a dog.
Oh yeah, I mean, I just said like, I mean, if the verb is like to see, or if the verb is just a copula. Like that was not a well thought out example.
Okay.
Like the point was just like, I mean, in GF, like in the Research Grammar Library, there is just a like there is a general. Oh, sorry. Yeah.
Oh, okay. So I'm I really don't know anything about GF. So I was wondering if you said the functions have to be invertible. So I wondered about like what do you do about local or, you know, let alone global ambiguity?
Yeah, I mean, in case of ambiguity, it's like when you parse something, then you just get several trees.
Okay.
I mean, it's completely possible to write GF grammars that like it goes completely crazy. Like let's say you have an empty string in some strategic place, and then you have a function that, let's say, have an empty string as an adverb, and then you have functions that can like accept any amount of adverbs, and then it just goes crazy. Like.
Mm-hmm.
So now that you talked about parsing, I'm curious what kind of parser is created inside GF. I mean, there's these probably not an LR parser because you have ambiguity.
No, like it's a GF parsing, so it's the modified version of the early parsing algorithm. So like I mean, it's a GF is so it's like between mildly context sensitive and something. But like the basic parsing is like it's a context-free parsing algorithm that is modified so that it like you create new productions from scratch. So it's like you can have infinite amount of productions that you can add them all the time. But that's as far as that's as much details as I'm aware of.
Okay, thanks.
Yeah. Okay. Yeah, I mean, I'm going to end this with live coding, so we can maybe take if you have like a question like how does this work in GF? So that's probably a like better time for those. I'm just gonna go through my slides first. But if you have questions on anything I'm showing on the slides, like that's just you ask. Okay, so yeah, so the theme subtyping December. So I'm going to talk a bit about subtyping. So I don't know what's your background, so if this is super boring, just try to not fall asleep. So the basic subtyping relation is that like whenever we can use a subtype in any place where we could use a supertype as well, because like if we have a function that just takes this record with the string, then we might as well give it something with the bool, and it will just ignore the bool because it doesn't need it. So yeah, you have subtyping basically applies for two types of things. Like you have records, and so it can be like the first record can have the subtype can have more fields than the supertype, or the subtype can have a field that is the type of this B field is a subtype of this B field. Like it's the same name, but this is an empty record and this is a record with a Boolean. And I guess this is also technically called subtyping, even though it feels kind of trivial. That's okay. So the records in different order are also subtypes of integer. For functions, so what can we replace one of these functions with the other? Do you have, like, you can just say if you, or if this is so trivial that you're bored, so just.
Well, somehow the type of F is a subtype of the type of G.
Yes. So, like, yeah, anything that if we can give something to G, we can also give it to F. And then if we maybe we have the output that F gave us, like this record with two things, like you can always use that output in place of this G, because the return type is a subtype of G's return type. I'm actually going to show like this example, but with some actual, like, I mean, something less abstract in the when I'm done with my slides. Okay, so now let's get back to GF again. So GF has very, like, yeah, it's nice syntax for, like, GF supports subtyping pretty okay. So you have this star. I think that's also, is it also the syntax in Haskell?
No.
Oh, whatever. So you can extend a type like this. So yeah, A is a record of S with a string, and then B is something that has S and S2. And it works the same for terms. So small a is a type of big A, and small b is a type of capital B. And so now if we have a function that takes an A and returns an A, and we can as well give it a B as an argument, and it doesn't complain. Whatever this function body does just ignores the other string. It just accesses the S field. Okay, so that's with subtyping. And depth subtyping, that's it works also. So here we have some. I define some bools so that we don't have to just deal with strings. I think if you're familiar with Agda, you should appreciate this. So now the question is, does this GF have depth subtyping? Is D a subtype of C? So here we construct some values, like a small c, which is of capital C. And yeah, so this is the syntax for empty record in GF. And now we have a function called G. And yeah, it accepts both C and D, even though D had originally a record that was completely something else. So when I was testing, right, sorry. So let's, just to confirm that it doesn't accept just anything. So here we have some type E, which has also a field called C, but it's not a record, it's just a bool. And yeah, here the GF type checker is complaining that expected, this is something that has C, which is an empty record, but it got instead something that has a bool. And just, this is not supposed to work. Like, it's just with subtyping, basically, that you can't give it an A because it's still expecting something that has an empty record. So now let's just make a small variation. So we had this G function here, which just used its argument as is, but replaced its C field with an empty record. So now we have a variation G prime, which again takes whatever fields the argument has, but then okay, so since the it takes a C, and we know that C has here we see the C has a field called small c, which is a record. So we can do this, like we extend the C field of G prime's argument with an empty record. And so just so you see that empty record is the identity for a record extension, so there is nothing weird happening here. Like this is what we expect. So now if we apply G prime to C, so this is completely expected because C's C field was an empty record, and here we extended an empty record with an empty record, and we got an empty record. But now if we apply G prime to D, which has the C field is actually a record with some Boolean, with a true here. So if you had a programming language, what would you want this function to do here?
You already said that the empty record was kind of the identity with respect to that extension, no? So I would expect nothing to happen. I mean, it should just reuse the original field with the B in it.
Yeah, but like, yeah, that's kind of like I would also expect, like, given that these happen here, but then if we look at the return type of G prime, is also a C, and the type capital C does not have a record with a Boolean in it, so that would be an error, like type error. So yeah, this is what GF actually does. So it just, like, it doesn't extend, it just replaces it. But I think this is very marginal. Like I've been writing linguistic grammars in GF for like 10 years, and today I was preparing for this presentation. That was like the first time I ever even thought of asking this question. And like, I think there are not that many people who would find this like a critical thing in their grammar.
But if you kept the original value of C, then, I mean, there is a subtyping relationship between D and C, right? Every instance of a D is also a C. So I don't see why you actually have to change the value for the typing to work.
Yeah, that's true. Yeah. Yeah, I mean, GF is not very consistent. Like I don't have a slide about it, but I was like playing around with other things, and like there I found that like it actually behaved like you said, that it returned something. Like, yeah, I think I can show it maybe later.
I think there was a question in the chat.
Oh.
The
right. Behavior you demonstrate looks like there would be some kind of eta expansion happening for records, like everything of type empty record is expanded to this diamond, right? So
yeah, diamond is just an empty record. So.
Yeah, and if you know by the type, like C, capital C has for field lowercase c has this unit type, so you can expand everything to this diamond.
I'm not sure that's the way eta expansion should work for the empty record, because it's not strictly speaking a unit type, right? It's more like a top type.
Yeah, that was something I was also wondering, or going to ask, what exactly is this empty record? Because in example, the type bool is not a subtype of empty record, but only if you wrap pool into a record, right? So it's not top somehow. It's something more special. Yeah.
It's top for records, but not for other stuff. Yeah, it's funny.
Yes.
Yeah, there was a question in the chat also, just not to forget that.
Right. So, right. Can you do nominal typing by wrapping the? Just, I'll put the question. Is it showing on the screen now or?
No.
Okay. Wrapping the product onto another type. It's some type. I think I don't actually know. Like I think like I mean in GF, like this type of type constructors, like you can only do it in a param. Like I mean, that's the only place you can do like algebraic data types. Like you can't just like take a constructor like that and like put it into an opera. I have actually no clue, but we can look at that when I get through my slides and like do some live coding. Yeah. Okay. Right. Okay, I'm almost done with this. Like just so. Right. So here we have the permutation subtyping, which like I think my reaction was basically like, well, what programming language does not support that? But the question answer is that GF before July this summer, but like there was actually a bug like this, that argument list C color S size not among S size C color. But this was actually a bug and it's fixed now. So now GF supports permutation subtyping as well. I think that this mail was sent as a around the discussions around that bug. Like Arne was like revealing the process from GF's type system. Like yeah, overloading, disambiguation, partial application, type inference, blah, blah. This system has not been formally specified, but grown organically by addition of things that turn out useful in practice. Hence, it can be the case that a complete and sound system combining all these features is not even possible. Some formal work is needed to verify this. So this is like, if anyone is looking for a project, so I think there is like, there is some work to be done in GF's type system. I heard you people like types. Right. So that was the end of my slides. Any questions now?
So I was just wondering if you would say like what are some of the directions if you were going to try to investigate the type system, and like, yeah, obviously this stuff we didn't cover, like higher order abstract syntax and dependent types and stuff, but which, I don't know, where would you put your nose and start looking if you were going to try to like find counterexamples that Arne proposes?
Yeah, like yeah, I think, I mean, there is a lot to choose from. Like I basically like, I never used dependent types nor higher order abstract syntax seriously. Like I think some years ago I made something like tiny toy example of trying to emulate categorical grammars in GF, but people who know categorical grammars told me that this is completely not how categorical grammars work. But that one used higher order abstract syntax. So I think, yeah, you should ask Herb. Herb should be here.
So I can see potential problems coming up with overloading based on static typing and combining. Then somehow your types are not unique, and then Well, the overloading is dependent on the type, but if you have subtypes, then I mean, it gets hairy. I would say.
Yeah.
But maybe it's feasible, right? I don't know. It sounds a bit scary.
Yeah. Like I think, I mean, so my background is like in computational linguistics, and like, so all the time I've used GF. Like I use it to, like I use GF so like I read a grammar book. Like I have a let's see, like I read a grammar book like this, and or something like that. Oh, this is a good one actually. And then I think of how to represent this nicely in GF, and I think so. Subtyping is something I actually use a lot because it's very practical for me to like to write more reusable code and not to repeat myself. But like any of the other GF's hairy types are kind of like I don't need them in my daily work. So like the problems that I have are actually like sometimes I think that as a human, like I know that of course I mean this, but then I need to write an explicit type annotation. But like I don't have actually a concrete example right now. But that's mostly like my complaint from end user perspective is that sometimes the compiler type inference is not as smart as I would like it to be. But then I just write an annotation.
Mm-hmm.
Okay. All right. So now I'm going to switch to. Where's my editor? Which is okay. I think I just switch. Okay, now you see a text editor, right?
Yes.
Okay, great. Okay. Yeah, I had I had a plan. Right. I'm just going to one. So I was going to show you like an example of the function subtyping and like how this, like I think like I know everyone who is in initial types club must probably like types quite a lot, but like this is kind of like a sales pitch, like how does a computational linguist like types? So I would just like this is actual like this is as close to my actual daily life as possible, like without requiring this much förkunskap. So, okay, so now we're going to talk about grammar. So let's talk about determiners and determiners and nouns and noun phrases. So these are helpers. So yeah, just English or some vaguely imaginary language. Let's see, a determiner is stuff like this. So it has a string, it has a number. So maybe those are enough. So now we have to define the number. So And let's have a noun as well. And that should be a variable. So it's like it has an S field, which is an inflection table from string. And then we have a category noun phrase. So the noun phrase, which already has a quantifier, so we know if it's like one song or many songs, like this song, these songs. Then it has some like inherent number itself. So like then later on, if we want to use it as like, we need to know if it's going to be a subject of a verb, then like if we're going to say that like this song is good or these songs are good. Okay. So far, so good. Yes. So let's see what, right. So we were going to talk about subtyping. So now let's make, so here's the function that takes a determiner and a noun. And we just, all right, actually, let me add one more thing. It's like, we could also have a type which is pronoun. Then a noun phrase can come out of either from a noun or a pronoun. So this is, so now that's why we need another field that is something like is from bool. To define our bool, we could just call the param origin and then say that origin from pronoun, whatever. Oh, details. So now, okay, now we have this function is we take a determiner and noun and make a noun phrase. So it will have the S field will be the, so we start with the determiner's S, concatenate it with the noun's S, and then we choose the determiner's number from there. Number is just determiner's number. It's like if the determiner is this, then it's going to be singular. If the determiner is these, then it's going to be plural. And we know that this is from always going to be false. Because that's just like this. We know that okay, the arguments are just noun. Like we would have another, like we could have another function that is like use from. And in this case, like the is from field will always be true. Okay. So now, okay, right. We actually should define some types first. No, actual values terms of this is. So let's say this, which is constructors. Files, right? Okay. And now it's lexicon. So now we can actually so CC, which is short for compute complete, .np is yeah. So the string is this song, and it's not a pronoun. Okay. So here comes the subtyping. So now we want to extend our grammar with some interrogatives. So we not just to say a song, this song, but we can say which song. And so that's so we have some new types of that. So we call it Interrogative Determiner. And so that's also the same, like you can say what song, which songs. So it also has an inherent number, and it obviously has a string. So this clearly has, so this is at least the same as that. So now I'm just making this up, but this similar thing happens like all the time. So let's say that, okay, we also need for some other purposes, like some other function needs to know if it's like some other feature, like is it like who, which, when. Actually, maybe they all start with WH. Let's say that, okay, maybe it's a person. Like, let's say that, okay, you treat it differently if it's who than if it's what. Like, yeah, this person. So now this idet is a subtype of that. And so the result is, so instead of noun phrase, we're going to make it an interrogative phrase. But here, maybe like we cannot, there is no way to construct an interrogative phrase out of a pronoun. So, excuse me. So this is-from field is actually redundant here, but it will still have a string and an inherent number. So actually, we're going to make this into this is the super type, and MP is a subtype. It extends the IP interrogative phrase with like one more field. So now, compose. So and now if we have so we have this function det_np that takes a det determiner and noun into a noun phrase. And now if we want to have idet_np, which takes an idet noun and returns an interrogative noun phrase. Now since the idet is the subtype of det and np is a subtype of IP, so now we can just say that, well, this is the same as det_np. I mean, maybe this is all obvious to you, but like I just have to write it like this in order to wrap my head around this like subtyping relation functions. But yeah, like this kind of things, like that's the point. Like that's what's very useful for me in my daily life in writing grammar. Is that like some things make a distinction in some places, but there are still many places where they don't make a distinction, and then I don't need to write all this because these two lines would be the same. But and this is irrelevant for this idet_np function. But I can just ignore that it is there and just write it like this. So let's test. So let's make actually. Called this. What? Okay. So now this is I can type this here. So you see and so now let's edit NP on. Yeah, so this is actually flags. Right. So this is actually now we see the thing that even though IDET-MP has a type, like a return type is IP, which does not have the is-from field, like this will still actually return it. So the result of IDET-MP is a record with 3 fields. So like whoever said like earlier that it shouldn't matter that the C field contains a B equals true because it's still a subtype of an empty record. Like so in this case, like this still contains this is from field. So I think GF is just, I don't know if it's a difference that this was like, this is just like with subtyping and that other one was depth, but no. Yeah, that was the, that's basically what I wanted to demonstrate with these functions. Do you have any questions or any other things you want me to show? Or other things you want me to type in here?
So I'm just curious, do you always just use it when you're defining these auxiliary functions? Because obviously that's ultimately going towards the construction of a concrete syntax. But do you kind of think of subtyping when you're in this phase? And then once you have your concrete assembled, that like detail no longer crosses your mind? Or is it kind of, I don't know, do you think in terms of subtyping when you're designing grammars, or is it very just case by case? Sometimes you think about it, and sometimes you don't.
Yeah, like I mean, it's mostly like it's a feature of concrete syntax basically, because like if I design an abstract syntax, I don't really know what kind of distinctions I will have in whatever language I'm implementing the concrete syntax for. So then it's just like, yeah, I mean, it's just basically, I'm not sure how much I think about it, like when sort of planning or like writing abstract syntax, but if I'm writing a concrete syntax and then I know just like, oh, actually I don't need this thing here, but oh, I can still, it doesn't matter. Like it's a super type, it's the subtype, I can throw it away, but like I just find that this kind of thing like happens to me often. Like I start writing something and then I notice that like, oh, actually this is almost the same, but like, oh, I can just ignore the thing that is extra.
Okay, thanks.
Right, we had a question from the chat. So actually, where's, oh, I have no clue how to, oh, here. Okay, so Here's the question. Right. Yeah, so I think, so I mean, you can use records as parameter. Okay. Okay, right. It's answered. Okay, great. Yeah. Yeah, so I think like you wouldn't be able to write something like some constructor here. Let's see. Yeah, okay. Constant not found. Okay, if I make it into a constant, let's see. Function type is. Yeah, okay. I mean, I'm not expecting this to work. This is just. Oh, right. Now we're getting. Yeah, I think it's just like, yeah. But okay, yeah, the question was answered anyway, like it was. Any other things anyone wants me to type in a editor?
Okay, maybe we can thank the speaker and then we can continue after I switch off the recording. Thank you for the talk.
Yeah, thanks for listening to me.
Okay, we'll stop the recording now.
Yes.